Welcome class to today's video. Today's video is a very short lesson on the intro to chapter 8. If you didn't get a chance to watch this in class and you're watching it before you come back from Thanksgiving, I hope you had a wonderful holiday and I hope you enjoyed break. This video will definitely not take too much of your time. Let's start with a polygon. And what is a polygon? A polygon is a closed figure that's formed by three or more line segments called sides. Polygons have sides and vertices. They can't be rounded and they have to be closed figures. So let's take a look at some polygons. So I'm going to put a line through things that are not polygons on this page. Remember, polygons are closed figures. So first of all, not a polygon. Polygons can have rounded corners, not a polygon. As long as it is closed, there's only one line at each vertex, which makes it closed, then it's a polygon. So even though weirdly shaped, it is a polygon. Here, even though weirdly shaped, it is closed, and there's only one intersecting line at each vertice. When we come here, although this is closed, if you look here, there's more than two lines intersecting at the same vertice. So this is not a polygon. It's technically got something kind of going through the middle, so it's not itself a closed figure. Yes, it's a polygon. Yes, it's a polygon. Yep, it's a polygon. Nope. Hopefully you know why. It has rounded edges. Yes, it's a polygon. Again, it's that not closed figure because it has more than two lines intersecting at one vertice. And then not a polygon because it has curved lines. So everything else here is a polygon. You have to be able to pick out any of these polygons from any directions. So for example, if it has three sides, you have to know a three-sided polygon is what we call a triangle. A four-sided polygon is what we call a quadrilateral. Quadrilateral. Five-sided, pentagon. Six-sided figure, we should all pretty much know, hexagon. Seven-sided figure, please be careful, it is not septagon, that's what a lot of people think, but it is heptagon. A seven-sided figure is what we call a heptagon. Eight-sided, most of us already know, octagon. Nine-sided figure is a nonagon. A 10-sided figure is what we call a decagon. It comes from decade, 10 years. Decathlon, 10 events. And then 12, I skipped 11. Doesn't have an exact name, but 12 tends to be pretty popular that the textbook uses or will use. And that's just 2, which is do, on top of 10. So it's dodecagon. And then last, any other polygon besides probably any of these on the list, you might have to know I don't even think they're going to ask. There might be one that's like, I don't know, 15gon, which would be pentadecagon. So you would know pretty much what 15 sides is. But if it doesn't have a name or the textbook isn't going to use it, they're just going to call it n-gon. So for example, 11 we skipped. If I want to use an 11-sided polygon, I'll just call it an 11gon. So you would know it has 11 sides. If I want to do a 30-sided polygon, then I'll just say 30gon. One thing we have to know is there's two types of polygons. A polygon is considered convex if you extend each side of the polygon and there's no segments that go through the polygon. So if I grab this line and I just extended these, you'll see that this line and this line never go through the interior of the polygon. So I just move those over. These lines never cross through any part of the interior. So that's how we know it's convex. If a polygon caves in anywhere, it is considered concave. And for example, if I extended this line right now, right here, it's going through the interior of the polygon. So it is not convex. It caves in and it is concave. Let's take a quick example. We have 4 examples. Is it concave or it's convex? So our first one, would you think it's concave or convex? It's not a polygon. Remember, because it's cutting through that more than 2 lines are meeting at one vertex, then it's definitely not a polygon. So that was a trick question. Number 2, it is concave. And it's concave because if I extended this line here, it would run through the interior. Number 3, convex, because no matter what lines I extend, it will never go through the interior. And then, of course, number 4 is concave. If I extended this line right here, it would cut right through the interior. Besides knowing concave or convex, there's only one other thing we have to know about polygons, and this is it. In a equilateral polygon, all the sides are congruent. In a equiangular polygon, all the angles in the interior are congruent. Sorry, I think it's supposed to say are congruent. So we already know what equilateral means, and it means that all the sides are congruent. We know what equiangular means, and it means that all the angles are congruent. If a polygon is equiangular and equilateral, then that polygon is what we call regular. A stop sign is a regular polygon. Things that look normal to you are regular polygons, but by definition, regular means that it is both equiangular and equilateral. Okay, here's an example. All of these would be regular polygons, perfect sides. Each one of these angles would be equal. So in a triangle, a regular triangle would be an equilateral triangle. Therefore, all the angles would also be equal. So if I looked at this picture and I said determine if it's equilateral, equiangular, or regular, tick marks show it's equilateral, angle marks show it's equiangular. So all I would need to say it's regular, which covers both. I would not have to list both equilateral and equiangular. Lastly, here's an example of a type of problem we could have if you know that a polygon is regular. The head of a bolt is shaped like a regular hexagon, so I tell you it's regular. The expressions are shown for the side length of the bolt. Find the length of the side. So if you know this polygon's regular, then all we need to do is set the 2 equations equal. 4x plus 3 equals 5x minus 1. Subtract the 4, you get 1x. Add the 1, you get 4, so x is 4. So because I asked you to find the length of the side, we have to then just plug 4 back into either one. So I took 4x plus 3 and I did 4 parentheses, and then I just put 4 plus 3. Hold on, that's not right. I'm sorry, it's 4 times 4 plus 3. So it's, 3. So it's 16 plus 3, which equals 19. So what is the side of our bolt? 19 millimeters in this case. That's it for polygons. I hope you come back from your wonderful break, your 4-day weekend, and that you know the various types of polygons. If you don't know them, please know these by being able to identify them, and then know convex and concave, and then what a regular polygon is. If you know that, you're good to go. Thanks, guys. Have a good weekend.